Okay. Good evening, everyone. Before we going to start the ESXi host networking session 5, we switch policies and lab. First, we'll discuss the quick questions. One of the question is, what is the difference in DV switch and vCenter server? We will discuss the what is the difference. vCenter means it's a VMware, one of the virtualization management software, vCenter server. This vCenter server purpose is to manage multiple ESXi hosts. Until now, we discussed the concepts of how to install a single ESX and how we can manage a single ESX server. In our previous sessions, we discussed in order to manage a single ESX server, we need a either graphical user interface. We can use vSphere host client. For command line interface, we can use either a SSH session or you can connect to the ESXi host direct command line interface. So two methods we verified. Suppose in our organization, our ESXi host count is we are planning to increase. I plan instead of one ESX, I plan to use a 10 ESX at a time. To manage all our 10 ESXi hosts, it's not recommended to connect to the 10 ESX in a 10 consoles. So for easy administration and also in order to get some additional features in the vSphere environment, VMware introduced another product, the product name called vCenter Server. This vCenter mainly to manage multiple ESX servers. Multiple ESX means minimally 2 ESX is required to maintain the multiple hosts. We need to install vCenter. Even not only two, even you have a 2000 ESX also. This vCenter server tool is supported to manage all ESX in a single console. That is the vCenter server. And when it comes to the DV switch, yesterday we discussed the two types of virtual switches. One virtual switch is vSwitch. vSwitch is a by default switch. It's created only on the ESXi host level. But the DV switch, yesterday when we verify the ESX host networking tab, there is no option for the DV switch. DV switch name itself, it says distributed virtual switch. This distributed virtual switch feature we will receive only in the vCenter level. This DV switch is one of the vCenter server feature. In our vCenter server, there are 30 plus features like vMotion, fault tolerance, HA, DRS, snapshot, clone, template. There are around 30 plus features available in the vCenter server. Within these 30 plus features, one of the key feature is DV switch, distributed virtual switch. So if we learn all the vCenter server key features, you will become a VMware systems engineer. And you can also eligible to write the VMware certified professional exam also. Okay, so once we familiar for one single host management, our further concepts will start from a vCenter server installation, and then we'll start discussing the all vCenter's features one by one. Is it clear?
So,
Okay. Okay. Before we start, any other questions?
okay.
If no questions, we can start with today's session. So today is we are in the ESXi host networking session 5. If you observe the our previous sessions, we start with a basic networking devices. We discussed what is the main networking devices, what is the basic requirement to form a network, and we also discussed the IP address classification, and how many types of IPs available, and what IPs are reserved for our local area network and wide area network. And we also verified the how many reserved IPs are available within a class A, class B, and class C. And yesterday's session, we observed the ESXi host networking. What is the importance of virtual switch? And we observed the port groups, how many types of port groups we have. And we also observed the ESXi host vSwitch architecture, how the architecture will be. Even if we are using a ESX networking, still we have to have an idea on both physical network knowledge as well as virtual network knowledge. And as a VMware vSphere administrator, our main focus on the ESX host network layer, and for the physical layer, how to configure VLAN and how to prepare a VLAN trunking and all. These concepts is most of the time it's taken care by network administrators. Even if you learn the physical networking concepts also, it will be like a value added for your resume. Okay, so let's start the further concept of vSwitch. We are going to discuss the vSwitch policies today session. And so this is the outline for the today's session. vSwitch use cases. Use cases we discussed yesterday. I will just quickly recap what is the use case we discussed yesterday. Based on the use cases, we'll perform the ESXi networking lab. And in between, another concept is ESXi networking, vSwitch policies. And within ESXi networking, we can also observe a few basic commands. These commands will be useful when you have any issues on the graphical user interface, when we are unable to access the ESXi host via graphical user interface, like vSphere host client. If you are unable to access during that troubleshooting scenario, these commands will be helpful to connect the ESX via command line. Even if you are unable to connect remotely using SSH, you can connect directly on the DCUI mode, direct console user interface mode. Go to the shell prompt by pressing Alt F1, and then you can run the direct ESXi shell commands also. And the commands for the ESXi shell command and SSH commands both are same. Okay, so these commands also will discuss few commands. It will be helpful during the troubleshooting scenarios. Okay, so we'll quickly recall the yesterday session. We switch use cases. Okay, so you switch use cases. I'm taking the examples of two use cases. So the first use case is use case one. This use case one, if you observe this conceptual diagram, we have only one virtual switch. Within the one virtual switch, as per our VMware vSphere configuration maximums, each virtual switch it supports maximum 4088 ports. Okay, but within this one virtual switch, if you want to use only one vSwitch in your environment, that is one use case. Within one switch, we can create two types of port groups. So how many port groups we have? We have VM port group, VM kernel port group. And VM port group means it's only for virtual machine network. And VM kernel port group for ESXi management and its services. Services means vMotion, provisioning service, fault tolerance. This all comes under the vMotion services. This service also mainly for vCenter features. I will explain detail during the vCenter concept. Okay, but understand that VM kernel port group mainly used for the ESX host management and its services. And VM port group, it's easy to remember. The name itself says virtual machine. So that means it's mainly for virtual machines network. Virtual machines network means either it is a production network or it is a test and development network. Whatever the virtual machine is it a production VM or test VM? We require a minimum requirement to access your virtual machine from within a host, or if you want to access the external world, we require a virtual machine port group. Similarly, for ESXi host management, we are using a one of the management port group, and for vMotion purpose, we need to create a additional VM kernel port group. Suppose if you want to access the storage, even in the storages, we have a multiple types of storages: local storage, network attached storage, iSCSI SAN, and fiber channel SAN. iSCSI also one of the storage. iSCSI full form is Internet SCSI, Internet Small Computer System Interface Storage. Even while you are accessing the iSCSI storage also, we require a one separate port group to manage our storage network. Okay, so that is the reason in this use case one, we created a five port groups, two VM can virtual machine port groups and three management port groups. So this is the one use case. But in this use case, we need to observe that we have only one virtual switch. There is no additional virtual switch. And even if you observe, if you see the below screenshot, this is the actual virtual design. Even when you log into the ESXi host, you can see this virtual design view only. And the above one is like only the conceptual view. But in the virtual conceptual view also, you can see the same vSwitch topology. The middle gray color icon represents as a virtual switch, and the right side you can see physical adapters. In this diagram, it's showing us two physical adapters, VM-NIC 0, VM-NIC 1. And these NICs are not limited for your two NICs, but the VMware best practice is every virtual switch we must and should have minimally two NICs. Why we are using two NICs is it's a redundancy purpose. And the maximum NICs, we can add 16 NICs if you are using a 10 Gbps speed, 20 Gbps speed, or 25 Gbps speed. Suppose if your network speed is increasing to 50 Gbps, the limit will be reduced to maximum we can add 8 physical adapters only. So in this diagram, I'm just trying to show two adapters are added, and also the same virtual switch we created a two port groups. These two default two port groups are we no need to create. When we install ESX server, by default it will create the two port groups automatically. And one port group clearly represents as management network, and another port group is as a virtual machine network. And I also remember another important point is for virtual machine network, we no need to provide any IP address on the port group level. We can provide IP address only on the virtual machine guest operating system level only. When comes to management network, we need to provide the IP address for a VM kernel port group level. Suppose you can create port group for port group. One IP required for a management port group. You want to create another management port group, which is vMotion port group. For vMotion also we need a additional IP address. And similarly, if you want to create iSCSI port group, iSCSI also one of the VM kernel port group. For this also we require a additional IP address. So that is the requirement for management port groups, or we can call it as VM kernel port groups. Okay, so this is a use case one. When let's observe the use case two. So in the use case two, the only difference is if you observe the below conceptual diagram, we have a instead of one virtual switch, we have a five virtual switches. Even though if you use a multiple virtual switches, by default each switch support 408. All switches supported 408, but within the all five switches, ESX host maximum supported active ports are only 4096. It won't support for more than, even though if you have a more than 4000 ports, let's say among all the five ESX hosts, if you count 4000, 4000, 4000, 4000, so 5 ports means it's almost like a more than 20,000 ports. But even though if you configure 20,000 ports also, ESX server supports maximum 4096 active ports only. So that's why I mentioned in the right side, max 4096 ports per host. Host means ESX server. So in the second use case, we need to observe that for each port group, instead of configuring all port groups on a same virtual switch, we just split it into the multiple virtual switches. Okay, that is the use case two. But in the virtual view, when we log into the ESX console, if you see the above diagram, when we log into our demo ESXi host, when we select to the ESXi host networking, when select the port groups tab, you can find all the port groups. See here we have VM network port group, management port group, production, test and development port group. For this all port groups also you can see active ports. So these active ports, entire ESX host, maximum active ports are 4096 only. And VLAN ID is optional. If your physical network have a VLAN number, we need to enter those VLAN numbers here. If there is no VLAN information in the physical network, you can just leave it blank. Default value is 0. And this is a consider as a standard vSwitch port group. So standard port group. And vSwitches, if you observe that same like our use case 2, we have a multiple vSwitches here. First two port groups VM network and management created on vSwitch 0, and the production port group created on vSwitch 1, and the test and dev created on a vSwitch 2. Okay, so today we are going to perform the lab for these two use cases. We can take one ESX host for use case 1, and the second ESX we can plan to do for a use case 2. Okay, now we're going to discuss the ESXi networking vSwitch policies. When we creating the ESXi host, if you observe the right side diagram, in this diagram, I mentioned as vSwitch 0. When we click on vSwitch edit option, within our vSwitch properties, when we click edit, we will find the vSwitch three types of policies. I highlighted the three policy names. One is security, NIC teaming, and traffic shaping. Okay, the same points I mentioned in our description. Policies that are set at the standard switch level applies to port groups on vSwitch by default. So when we create one virtual switch, we are not going to create all these policies manually. It's a default. It's created a three vSwitch policies. This three vSwitch policy available vSwitch policies are security, traffic shaping, NIC teaming, and failover. This NIC teaming, we can also say NIC teaming and failover method, or we simply say NIC teaming. Any name we can use. Okay, and the key point for this all vSwitch policies are defined at the following levels. The following levels are either you can apply on a vSwitch level or you can apply on a port to group level. vSwitch level default policies for all the ports on the standard switch, but port group level effective policies are policy defined at the level override the default policies that are set at the standard vSwitch. So sometime port group level we no need to set any policy. When you apply policy on the vSwitch, it's automatically override this policy to port group level also. Okay, now we're going to discuss in detail about each policy information. But this policy information, most of the real-time scenarios, we can make the all the policies same as it is. We no need to modify anything. But in the there are some situations either in the auditing purpose or there are some situation you want to analyze your ESX network traffic, you want to see your network IO control input and output control information. Those scenarios only we recommend to modify our vSwitch policy information. Or else always whenever we create a vSwitch or you can create a new port group, these policies no need to change manually until unless there is any requirement. Okay, but as an a vSphere systems engineer, we have to learn what is the importance of each policy. Okay, and because these policies are very important, you may get the questions in the interview or when you are attending for your VMware certified professional exam, you may expect few questions from this vSwitch policies. Okay, for that reason we need to understand what is importance of each policy. Suppose let's talk about the first policy, security. Within the security, we have a three types of policies, three security policies. That one security policy is promiscuous mode, and second one MAC address changes. Third one is forged transmit mode. And promiscuous mode, if you see here, I haven't do any changes. I just click the vSwitch edit settings and I took the screenshot. When we click the vSwitch settings, default these three policies are in a reject state. That means the policy is not enabled, it's in the disabled state. If you want to change it to the accept, we need to understand how the promiscuous mode behave. The promiscuous mode behavior is, it is acts like a packet analyzer. It acts like a packet analyzer. Packet analyzer means when you send any information from one system to another system, while sending the information, it is sending from source to destination or destination to source. For data transferring from source to destination, always it sends on a network packets level only. Even if you type the any command, if you want to check the ping status to our ESXi host, or type our ESXi host IP address, port 71. It seems it's, yeah, we are receiving the reply. When we receive the reply, always the send and receive will be in the packets only. So there are four packets sent, four packets received, there is no lost. So network information always sends in the packets. So that is the reason we are saying that promiscuous mode is like a packet analyzer between the source and destination. Whatever you send, whatever you receive, all these packets will be analyzed when we enable the promiscuous mode accept. Okay, when we select the accept, it will create some log information on the ESXi host VM kernel level. In our ESX class, we discussed the logs information. There is a important log is hostd log and VM kernel log. These logs will have this information. Whenever we enable the promiscuous mode, that activity log information will stored on the VM kernel log. Or sometimes few information is stored on the hostd.log. And this all the logs, where is the default location for all these logs? /var/log location. Okay, so I repeat, promiscuous mode purpose is it acts like a packet analyzer. Whenever we want to analyze any packets between source and destination, we recommend to enable this security policy. Okay, until unless if no there is no requirement, just leave it default. And let's discuss the another point. Another security policy is MAC address changes. The name itself says MAC address changes. In our basics of networking class, we discussed about MAC. MAC means media access control. Every network card, not only a physical network card, even the virtual machine, virtual network card also have a unique MAC address. MAC address, we also call it as physical address. If you want to verify from command line, open the command line, you can just type the command get MAC. When you type get MAC, you will find all the MAC address information. MAC address, we can also call it as physical address. You can use get MAC command, or you can type ipconfig slash all, and when you type slash all also, you will find every NIC card have a physical address. Okay, this physical address is the MAC address. But now here what is our point is MAC address changes. That means if you want to monitor any of the user is trying to change the MAC address on VM level or guest OS level. When they are trying to change the MAC address, you want to get the notification. Some so and so virtual machine MAC address is changed. When you need that notification information, we need to change the setting policy to accept. Suppose if it is in the reject state, even though if you change any of the MAC address on virtual machine level, there will be no notification. Okay, now you may get a question, how we modify the MAC address. If you want to modify the MAC address, let me connect to our lab system. Okay, let's log into our ESXi host first. Refresh. Okay, we log into our ESXi host. If I want to change the MAC address, right click the virtual machine, go to the edit settings. When you go to the edit settings, here, if you want to see our network card, just select the network adapter 1, expand. When we expand the network adapter card, we can see the information. It is connected to production. Adapter type is VMXnet3 and MAC address is automatic. There is a MAC address. But currently, if you see the virtual machine icon, it's in the green color. That means it's a VM is in the power on state. When the VM is in power on state, we cannot change the MAC address. So let's cancel. Choose the power of virtual machine. Go to the edit settings. When we select the edit settings, just expand the network card and there is an option to modify the MAC address. Okay. Currently it is showing all 0. Even if you want to set the MAC address to any additional MAC address or any of the static MAC address, we can set. When we set the MAC address, you want to see the notification message. If you want to see the notification message within our vSwitch level, that MAC address policy should be accept state. How we can see the vSwitch policies? Select our vSwitch 0. See, we can find the vSwitch details here, and under the vSwitch details, there is a NIC teaming policy, security policy, shaping policy. Shaping means it's a traffic shaping policy. Under security policy, you can see currently it's in the no state. Yellow promiscuous mode, 4G transmit mode also no. Even MAC address changes also no. This is the default options only. If you want to modify this setting for the security policy, just click on edit settings. And here you can change your security to accept. Just click on accept, click on save. So that is the way we can enable the MAC address changes option from the security option. See, now it is in the yes state. Similarly, if you want to enable the packet analyzer, same method, we switch edit settings, go to the security policy and change to accept. Okay, click on save. Okay, now the status is changed from no to yes. So the purpose of this enabling yes is whenever any traffic going from virtual machine to any of the external network, all the packets will be captured within our VM kernel level. Okay, so let's minimize. So we'll talk about the another point. Forged transmit. This is also one of the security policy. The name itself, forged transmit. Transmit means it's mainly for a outbound traffic purpose. MAC address changes for a within a VM level we are changing. We are getting the notified. That means MAC address changes is belongs to the inbound traffic. Forged transmit is belongs to the outbound traffic analyzation purpose. Okay. And now come to the another point is NIC teaming. NIC teaming, even if you read the name NIC network interface card teaming, teaming means it's a group of NICs. So when you team the group of NICs, minimally 2 NICs or more than 2 NICs, if you have a group of NIC cards, if you see our vSwitch use case also, within our use case in the production vSwitch, we have a three NIC cards, one, port two, port three. So if we have a three ports means these three ports connected to three virtual NICs and three virtual NICs connected to vSwitch. These three virtual NICs, if in case of any one port is down, you want to know which network card is down, and also if you want to have a multiple NIC card, there is a some purpose. That purpose is load balancing. The load will be distributed among the NICs. If you have more than minimum two or more than two, you can maintain. That is called NIC teaming. If you have two NIC cards, always the network traffic will be distributed between these two NICs. Okay, and the failover detection. If you see the failover detection, the name itself says failover detection. If any network card is failed, you will immediately get the notification. And to notify switch, even if there is any switch level issue, also you will be notified. And failback, if when the switch is failed, when you set the failback to yes, it's even the switch is back to online, immediately you will the switch is connected back to our virtual switch. And failover order, in this failover order, currently in this diagram, in this screenshot, we have a two NICs, vmnic 0, vmnic 1. If you want to change the order for NICs, we can change using failover order. We can make one NIC card is a active NIC card and another NIC card is a passive NIC card, or you can make it as a standby NIC card. Standby NIC card means when we can make currently in this screenshot two NIC cards in the active state. Suppose you want to make VM NIC 1 in a standby NIC card. In case of active NIC card is down, immediately standby NIC card acts as a active. Okay, that is a purpose of failover order. We can change the order sequence, anything you can modify using failover order. Okay, and another connection policy is traffic shaping. All these points whatever we are discussing, promiscuous MAC and all, we have a description slides in the next slide. We have a separate description for each point. Okay, and traffic shaping also, within the traffic shaping, normally when we are sending the any of the packets from one source to destination, there is a bandwidth also matters. We need to set the some bandwidth for the, normally for the production servers we always recommend to go with a average certain bandwidth is required for the production VMs. So those bandwidth ranges depends on your physical network speed. You can set the bandwidth values here. You can set average bandwidth, you can set peak bandwidth and burst size. Okay, burst size means it's a calculation of actual bandwidth multiplied by time. And also the current status for traffic shaping, also default status is disabled state. If you want to enable, you can enable and configure these bandwidth values. Okay, so now we'll start discussing some more points on the security layer. So we'll discuss first security policy, then NIC teaming policies, and finally we'll discuss the traffic shaping policies. We switch security policies. So just now we discussed the three options, right? Promiscuous, MAC address, fortune. So I just given the notes here. vSphere admin can define security policies at both the standard switch level and port group level. Promiscuous mode allows a virtual switch or port group to forward all traffic regardless of the destination. So whatever it is from the source to destination, if you want to analyze, you can just enable this promiscuous mode option. And MAC address changes, either it is a accept or reject, but when it is in accept state, inbound traffic when the MAC address is altered means it's a modification or change by the guest. If any of the guest is changed the MAC address, you will immediately get the alert. Altered means it's kind of notified only. Okay, and 4G transmit, this is also same scenario, but instead of inbound traffic it's a outbound traffic. Okay, now another vSwitch policy, which is NIC teaming policies. So NIC teaming policies also, if you observe the NIC teaming, enable multiple NICs to connect it to a single virtual switch for continued access to networks. If you do not have a multiple NICs, definitely there will be a network speed. When you observe the network speed, it may consume the over 80% speed. Suppose if you have multiple networks, the speed will be distributed among the NICs. Let's say when I use the one NIC card, the network speed is 80% usage. When we had another NIC card, the speed 80% distributed to 40, 40. Even in this screenshot, we have a two NIC cards. VMNIC 0, VMNIC 1. And the speed is measured in the Mbps, or you can measure also in the average percentage also. So here it is showing 10,000 Mbps speed. That means it's equivalent to 10 Gbps speed, full duplex. And also status, both NICs are active state. And another point is under the NIC teaming policy, in some cases, it will also enable load balancing if hardware fails. This load balancing also, it will activate automatically in case of any hardware fail, the load will be distributed to another NIC. Okay, this is not like a manual process, it's automatic process when you enable the NIC teaming policy. And some scenarios, we no need to bother on the virtual NIC level policy. Even our physical network layer, our physical networking team also will maintain the some load balancing mechanism. If you already have a physical networking load balancing mechanism, no, not recommend to manage on the ESX level. But as a concept, we should learn what is the purpose of NIC teaming feature. Okay, so load balancing policies, I just given the four policies. In this diagram, if you observe the load balancing, the right side there is a drop down menu. When you select the drop down menu, we will find these four options. Okay, if you want to observe these four options, virtual port, source MAC hash, IP hash, failover order, these options we can find from a ESX server. Suppose if we connect our ESXi host, select the vSwitch policies, expand the traffic NIC teaming policy. Under NIC teaming policy, when you choose the load balancing, eh, see the drop down menu, you will find route based on IP hash. Here, IP hash means we know it's a IP address only. We can balance the route load will be balanced based on the IP addresses, and also load will be balanced based on the MAC addresses. MAC address means every NIC code have a MAC address, and also load will be balanced on the port ID. Port ID means all our virtual machine connect to the virtual switch virtual port. Even the virtual port also it will balance. And another option is use explicit failover order. Failover order means we already setting the failover order below. Based on the failover order also load will be balanced. But we no need to worry about which option is recommended to choose. By default it will choose automatically. Okay, we no need to choose manually. It's a default, it will set based on our physical network connectivity. Okay, and the port information you will see in the switches itself. When you select switch 0, under switch details you will find the port information. Currently it's saying that 2560. Within the 2560, how many ports are in use? There are few ports are in use. The remaining ports are showing as a it's available state. Okay,
16 ports.
yeah, 16 ports are in use. 16 ports means it's used for few ports for your VM kernel and few ports for your virtual machine. All the ports are considered as a vSwitch ports only. Okay, now let's verify the another point. So the hope this point is clear. Load balancing in a any way you can balance the load. Either balance on a virtual port, or you can balance on a based on the MAC address, based on the IP address, or you can based on the failover order. Okay, so these same points we'll discuss some more detail. This is the complete NIC teaming and load balancing, a logical view diagram. Suppose if you see the logical diagram, in the left side I mentioned as a virtual NICs. So we have a virtual machines, four virtual machine. Each virtual machine have one virtual NIC card. Okay, one virtual NIC card. And all this virtual machine by rate, how it will connect? It will connect to the virtual switch only. So all are connected to virtual switch. So how we observed this is connected to virtual switches. When you go to our ESXi host, select the virtual machine. Here you can see the network setting. When we expand network setting, this virtual machine, which switch is connected, we'll find from here. If it is not showing here, just right click the VM, go to the edit settings, select the network. It is connected to production. Production is the port group name. So just observe where is the production port group is available. Go to the port groups, see production port group, it's connected to vSwitch 1. Okay, that's how we can verify the how it is connected. So same way our virtual machines, all virtual machine connected to virtual switch. So even if you want to verify your virtual machine, which switch is using, I'm repeating again, select the virtual machine, Go to the edit settings, verify your port group name first. What is our port group? It's a prod. Prod means production. I use the shortcut word PROD. Okay. Now go to the networking tab. Under port group section, see your prod port group and verify here prod port group is connected to which virtual switch. It's connected to vSwitch 1. Even if you want to see the diagram, click on vSwitch 1 and you will see the virtual diagram here. See virtual diagram showing this is a virtual switch. It connected to two NICs and it's also accessing our VM01. And you can see the virtual machine MAC address. Okay, so load balancing, you can balance the load based on the port ID, or you can balance the load based on the MAC address, or you can balance based on the network code. Anyway, we can use, but these options, which one to choose, we no need to worry. These options will set automatically by our ESXi host vSwitch. It will choose automatically. But concept wise, we should know what are all the options available in the load balancing policies. Okay, so this diagram, we observed four VMs connected to four virtual NICs. All VMs are connected to a virtual switch. From the virtual switch, it's connected to the physical NIC cords. If you see in this logical diagram, physical NICs, we have a three physical NICs. And also I put the dotted line for communication. Suppose from one VM, if you see the blue line, it's communicating from virtual NIC to virtual switch. From virtual switch to it connected to physical NIC, and from physical NIC to it connected to physical switch. From physical switch only we can access from our local system. Either it is our workstation server or any of the member server. If you want, in order to access your VM, this is the communication process. From the VM physical machine, you can connect to the physical switch to physical NIC. Physical NIC means ESXi host uplink. From the uplink, virtual switch to VM. This is how the communication will establish. The same way I explained for other VMs also, how the communication goes. Suppose if you see here, green dotted line, the direct communication here. And same way another way servers are trying to connect, I mentioned in the red line. Any communication, it will goes through the virtual switch. From virtual switch to physical NIC to physical switch, from physical switch to our actual destination VM, destination server. Okay, that's how the communication will establish. It's a vice versa. Even either you can connect from virtual machine to physical or physical to virtual. This is the same way it will communicate. Okay, and the route also based on the either a virtual NIC port or based on the vSwitch port or any of the MAC address also. Any of the way it will balance the load. Now the same points, its description is here. And NIC teaming and load balancing. We can configure various load balancing algorithms on vSwitch to determine how network traffic is distributed between physical NICs and NIC teaming. So how the traffic is distributed, that information we can verify from the load balancing algorithm. And as discussed, route based on the originated virtual port. Virtual port means just understand the point. The virtual switch selects the uplink based on the virtual machine port ID on the vSphere standard switch. So within the standard switch, we have a maximum 4088 ports. Within that port, one port dedicated for one virtual machine. Each machine dedicated one port. And also route based on source MAC hash. Source MAC means it's a MAC address. So virtual switch selects an uplink for virtual machine based on the virtual machine MAC address. To calculate an uplink for the virtual machine, the virtual switch uses virtual machine MAC addresses and the number of uplinks in the NIC teaming. Okay, and IP hash means it's mainly for the source and destination IP addresses. And failover order, whatever we set the physical NICs order, similarly it will work the NIC teaming and load balancing. Okay, if no uplinks in the active list are available, the virtual switch uses uplinks from the standby list. Even in the standby also we can add the uplinks. So how we can add the NIC as a standby, I will show you in the today's lab. Okay, now we'll discuss the some more points in the NIC teaming policy. So we discussed until now NIC teaming load balancing point. Now we'll discuss the remaining 4 points. What is network failover detection? The name itself says, suppose all of the sudden my virtual machine is unable to communicate from source to destination. Let's take about first VM. This is the red dotted line. when I trying to access from VM1, I'm trying to access a system one. This system is unable to access the VM. So how you identify this is default, it's not working. Either you can configure a internal monitoring tool to detect the alert, or in the vSwitch level, we have a option for notify network failover detection. So this failover detection is based on the link status only. Link status means we must and should have a link from our virtual switch to physical uplink to physical switch to our any of the server. If you do not have this link, how it will detect? It won't detect. It will detect only when we have in a same link. So that point also they mention here, link status only. Okay. So within, if we select the drop down menu, there is another option. We'll quickly connect to our lab system just to verify the policy. Which policy we are talking now? Nick teaming policy. So just click on edit. It's a loading state. Let's cancel and refresh. Go to the any of the virtual switch. Let's say we switch 0. Click on edit and select our nick teaming. Under nick teaming, we just now discussed the load balancing. And now we are discussing the network failover detection. This failover detection in a two methods. Either it will detect from a link status only or beacon only. Here beacon means beacon also one of the network failover detection mechanism. You can use either beacon or link. Anything is used. Okay, but normally if you're not sure about which one to use, just leave it the default values. Okay. So the same point I mentioned here. The VM kernel can use link status or beaconing or both to detect a network failover. So beacon probing means is one of the two available NIC failure detection mechanisms. So if there is any two NIC cards, one is fail, it will if you select the beacon, it will immediately notify you. Notification message says that one of the NIC card is down. Okay. Normally in the real-time environment, instead of configuring on the vSwitch level, we also use third-party monitoring tools such as SolarWinds NPM, network performance monitoring, or we can use VMware vRealize Operation Manager. These are all the monitoring tools. It will also help you in case of any network disconnection in our ESXi layer. Either you can use this method or you can use a third party monitoring tool. One best tool in the VMware VMware tool for monitoring is VROps, vRealize Operations Manager. If you want to use a third party tool, we have a plenty of third party tools like SolarWinds NPM. NPM means Network Performance Monitor. We can also use other third party tools like Nagios, WhatsApp Gold. These are all the monitoring tools. So these tools also we can use in the real time environment. Suppose your environment is very small environment. We are using a one branch office. For that branch office, I have only one ESX host. During that scenario, you can recommend to enable this option. If your organization is very big, we have a n number of ESX hosts. Instead of using these policies, we can directly configure this alert in a monitoring tool level. Okay. So we have a multiple mechanism. Anything can use. Clear? Now, the next point is VM kernel notifies physical switches of VM kernel notifies physical switches of changes in the physical location of a MAC addresses. VM kernel means our ESXi host main operating system core component. Even VM kernel also have a default functionality. Whenever any physical switch is done some changes, immediately you will get the notification on the vSwitch level. Okay, and the failover is implemented by the VM kernel based on the configuration parameters. Even the failover also how it will immediately is either on the failback mechanism or explicit failover order mechanism. Okay, so this is about the network failover detection. Now we'll talk about the another vSwitch policy. Until now we discussed the two vSwitch policies which are all security and nick teaming. Now we are going to discuss the traffic shaping. Let's go to the traffic shaping slide. Yeah, this is the traffic shaping policy. So this traffic shaping also pretty simple. If you see the policy name here, the default traffic shaping state is disabled state. Suppose if you want to enable the traffic shaping, you can select enable radio button and set your bandwidth level. Let's say our physical network bandwidth is 10 Gbps. Within the 10 Gbps, you can set some peak value. And normally most of the real-time scenario, no one recommend to utilize full bandwidth. Let's say my bandwidth is 10 Gbps. This 10 Gbps, if we convert into 100%, within the 100%, the max peak bandwidth we recommend to maintain 80% only. The 20% we always maintain as a buffer. It's not recommended to use additional 20%. So the peak bandwidth consider as a 80% and average bandwidth consider as a 50%, and the burst size is how much the time we need to send the traffic. So that information will set in the KB. Okay, that size of the data, either KB, MB or GB. That information you can set in the traffic shaping layer. And even they mention clearly the note, traffic shaping policy is applied to the traffic of each virtual network adapter. Virtual network adapter means it's a virtual machine NIC card attached to the virtual switch. Okay, this policy is applicable for each VM level. It's not applicable for all VMs. Okay, now let's read our description. Network traffic shaping is mechanism for limiting a virtual machine's consumption of available network bandwidth, either in the average rate, peak rate, burst size are configurable. And traffic shaping controls only the outbound traffic. Okay, it's control only the outbound traffic, that is traffic traveling from VM to the virtual switch and out onto the physical network. Same like our earlier diagram. It's a traveling from virtual switch to physical link to external switch. The same point we mentioned here. See, traffic traveling from VMs to virtual switch and out onto the physical network. Okay. Even if you see the analysis diagram, you can find outbound bandwidth in the here, and also the below is like a time. So time burst size means it's a bandwidth multiplied by time. So you can set the average and also the peak bandwidth. In this diagram, the average will be, this line refers as a average and this one refers as a peak bandwidth. Okay. Suppose if you want easy understanding, we can just move this to, this one is average and this one consider as a peak bandwidth. Okay, this line refers to peak bandwidth. Okay, so this is about the traffic shaping policy. So hope you understand the vSwitch default policies. So default policies are three policies: security, neck teaming, traffic shaping. But in the interview or VCP certification exam, you may expect the question like, what is the default vSwitch security policy? If they ask specifically to security policy, you can choose the answers, these three answers: promiscuous mode, MAC address changes, port jet transmit. Suppose they asked at the vSwitch level, what is the three policies means: security, neck teaming, traffic shaping. Okay. Within the NIC teaming, we have a multiple options: load balancing, network failover detection, notify switches, failback, and failover order. And also the traffic shaping also, we can set the types of bandwidth, like either you can set average bandwidth, peak bandwidth, and also the burst size. Okay, this is about the vSwitch policies. So hope we clear about the use cases, vSwitch policies. Now we'll discuss the our ESXi networking commands. So I'm not showing you the complete command information. I'm just trying to explain you the some basic commands. From that commands, you can find the help information to understand the rest of the commands. Okay, so I given few important commands here. So I given the functionality of each command and the actual command information. ESXi command, if you observe here, we have a two types of commands. Either you can use ESX CFG. CFG means configure ESX configuration commands, or you can use ESX CLI commands. CLI means command line interface commands. And we are talking about ESX networking. So if you observe here, all commands starts with ESX CLI space network only. And after that, we are adding the specific syntax information. Syntax, or we can say the specific namespaces we are using. So let's start discussing from one by one. Suppose if I use the first one, ESXCFG NIX. NIX means network interface card hyphen L. L means list, the same information I mentioned here. To get the available network cards. Network card or network interface card, NIC, anything we call it as NIX only. So to get the your available NIX information on ESX host, we can run this command. Okay. Suppose if you want to verify this command quickly, we'll just verify from ESX host level. Log into our ESXi host using SSH session. Okay, so I'm connecting the ESX using SSH session. So type our ESX IP 192.168.10.71. I'm connecting to one of our ESXi server. So click open. Okay, let me log into the host. Okay, we log into the ESX host. So let me increase the font for this. Okay, is this font okay? Okay, we'll observe the first command. What is our first command? ESXCFG nix -l. Even if you want to see all the commands in the first place, just type the command ESXCFG. CFG means configuration. You can press double tap. When you press double tap, you will find all the available ESX configuration commands. Okay, so now in this session, we are mainly focusing on the network related commands. Suppose within this available commands, which is our related commands, the first one is advanced configuration information, and the second one is dump part. Like when the ESX host is corrupted, it will create a dump. That kind of during the ESX corruption scenario, if you want to run the any dump information, you can run this command. And FCOE, it's like a fiber channel communication. Hardware iSCSI, this is also for a storage, and ESXi some information configuration information command, and this is for initialization, IP security, module information. MPath means multipath information. NAS means network attached storage information. NIX. So this is the command I've written here. NIX means our network interface card information. And also rescan also it will comes in a storage session. During the storage discussion, I will explain this command. And resource group, route also we can use today. Route is also related to networking. SCSI devices means it is also related to storage. Software SCSI, storage related. VMK NIC, this is also related to networking command. Volume, again the storage related command. vSwitch, this is our vSwitch related command. So if you want to observe this command one by one based on the available command, let's say I'm trying to observe the NIC command. You can just type, either you can just copy from here and paste here, or else you can just type manually. When we type ESX NICs, press enter, it will show you the available additional namespaces. See, when I type the NICs, it's showing the TSX NICs, options, NIC, and it's showing some additional parameters, and also showing the for the help you can use -h. Display this image. Suppose if you want to see the image, let me clear the screen. ESX CFG -NICs space -h. When we type the H, it is showing the help information. Within the help, if you see the one of the parameter is -l. If you see the -l, you will find print the list of NICs and their settings. Okay, the same information I put here to get the available network cards on ESXi host. So we'll type before verifying the command prompt. We'll just log into our ESXi host 71 host. Our ESXi host IP address is 71. Okay, within the 71, if you want to see how many NIC cards are available, just select our ESX networking tab. When we select the ESX networking tab, right side we have a multiple tabs. port to groups, virtual switches, physical NICs. So this is the relevant tab. So when you select the physical NIC card, see here in the graphical view, we can see how many NIC cards available. We have 5 NIC cards available, 0 to 4. And even all the NIC card driver is showing, MAC address is showing, and it's the auto negotiate, and also it's showing the link speed. Okay. The same options we can also find from the command line. When we type ESXCFG -nix space -l. So let me maximize the screen in the, let me minimize the ESX host. Let's maximize the screen. Okay, clear. I'm typing the same command again, ESXCFG -nix space -l. L means list. When I type list, see, you can find the systematic way, all the information, whatever we are seeing in the graphical mode, the same information you can see from the command line also. You can see how many NICs available, VMNIC 0, it start from 0 and ends with VMNIC 4. And all the NICs are connected in the PCI. PCI means peripheral component interconnect. And also the driver information, we are seeing the virtual machine because our ESX running on VM, that's why it is showing NVM. But normally in the physical, if it is really physical server, the driver will be a different driver. Okay. And if you see the link, all the links are in a hub state. And the link speed also you can find 10,000 Mbps, that means equivalent to 10 Gbps speed. And duplex is full, you can see every NIC MAC address. And when compared to graphical mode, there is no additional options for MTU and all. Let's like if you want to add those columns also in the graphical, we can seems only these options are available to add. All options are selected. But in the command line, we are finding the some additional information like MTU, maximum transfer unit. The maximum transmission speed is 1500, and also the description. Description is the, so suppose this network card is, we created network card in a VM level. So that is the reason it is showing VMX Net 3 virtual Ethernet control. But in the real time, if you are using a real production server, you will find the specific production server nickname. Okay. That is a description of NIC card name. For example, in our local Windows system, if I want to see the information, how we can see? We can go to the device manager, dev mgmt.msc, device management, Microsoft console. When we open device manager, even in the Windows system, if you want to see all your available NIC cards, in the device manager, you can see the option for network adapters. See here, you can find some actual physical adapter name is this one. This is a Intel brand. Okay. You will find the specific hardware model network information from the Windows system. Same way, even in the ESX server, when you connect the real production server, you will find the actual physical NIC card name here. Okay. This is a virtual machine, that's why it's showing VMware name. But if it is a Intel company or any other third party vendor, all the description is will displays here. Okay. So hope you have an idea on how to verify the ESX NICs-L command. Same way, if you want to see the another command, like again type ESXCFG, double tap, we'll see what is available commands. Let's say I want to see the virtual switch. See, this is the syntax. Type the vSwitch, and the same like Nix, if you want to see the list of virtual switches, -L, -L for list. See, in this list, you will find how many switches. Just read one by one. We have a vSwitch 0, vSwitch 1, switch name, and vSwitch 2. And we also have a number of ports. How many ports are used? How many ports we have? 2560, and used ports are 6. Configured ports are 128. Maximum speed. How many NICs are connected to this virtual switch? Whatever the options we are seeing from the graphical mode, the same options you can see from the command line also. See the same information. vSwitch is connected to two NICs, VMNIC 0, VMNIC 1. The same information available here. VMNIC 0, VMNIC 1. Okay. And port groups, how many port groups we have? VM network port group, management port group. The same information you can see from graphical also. Okay. And the same way for vSwitch 1 and vSwitch 2. If you see the vSwitch 1, what is available port group name? Prod. The same one we can observe from graphical mode also. Select the vSwitch 1, and you can see the port group name is prod. And suppose select the vSwitch 2, and you can see the port group name test and development. Okay. So the same name you can see here, test and dev prod. Okay, and what is the NICs are assigned for vSwitch 1? The NICs assigned NICs are two NIC cards, 2 and 4, and for the vSwitch 2 assigned NIC card is only one NIC card, VM NIC 3. Let's observe from graphical also. vSwitch 1, see we have two NIC cards, 2 and 4, and for the vSwitch 2 we have only one NIC card. Okay, so that's how either you can verify from graphical mode or command line. And if you want to know more about the vSwitch command, just type -h for help information. ESXCFG -vSwitch. Let me try without -h. Even without -h also you will find help information. These are all the some available list of commands. Okay, so whatever we are performing from the graphical mode, same thing you can do from the command line also. So even for help, same parameter -h is the parameter. Okay, so let's see our notes again. See, these commands I explained about the ESXCFG. ESXCFG, just now we observed NIC command, and same way we have another command is root command. If you want to show only the gateway information, the command is ESXCFG root. So let me type the same command. ESXCFG -root. When we type root, see it is showing our default VM kernel default gateway. What is our gateway is 192.168.10.1. This 10.1, when we log into ESX, you can also see from vSwitch 0 level. vSwitch 0 level, it is showing only the IP address. If you want to see the gateway, just click here. It will directly take you to the VM kernel IP settings. You can see from here. This is the IP address and 2550 is the subnet mask, and the gateway, it is not showing gateway here. Let me see the another wizard. VM kernel adapters default here, edit settings. Under the edit settings, just expand. Oh, here also we cannot see the gateway. So the in this scenario, still if you want to see the gateway, another method is you can connect to our ESXi host direct console mode. Here you can see the gateway. Okay, so here you know the how to see the gateway, right? Press F2, type our ESX root password. When you go to the system customization, go to our ESXi host management network, click on enter, and again select your IPv4 configuration. In the right side, you can see the default gateway. Default gateway is 10.1. The same gateway information, if you want to see from the SSH session, command is this is the one. ESX root. When you type the root, you will find the gateway information. Okay. So seems to be the gateway information. It's not showing in the graphical mode, only in the command line method. Okay. And another point, to get the available VM kernel port groups on ESXi host, the command is ESXCFG vmknic-l. So copy the command vmknic-l. So we can just type here ESXCFG -vmknic space -l. The name itself says VMK, that means VM kernel NICs. See, let me maximize. Let me retype again. See, it is showing the complete VM kernel NIC information, VMK0 only. So there is available NIC card is only VMK0. There is no VMK1 and VMK2. Okay. So similarly, you can just type practicing the all the remaining commands, and this command description also I given here. Okay. So it's pretty simple. We just now tested for ESXCFG commands. Even similarly, if you want to test the ESXCLI command, just go here. Let me clear the screen. See, CLI means command line interface, and press double tap. There are only namespace is showing as one namespace ESXCLI and another namespace is .py. Py means it's a kind of Python script. Okay, it's a default OS script. No need to change this one. What is the syntax it is showing? Space network. Okay, we'll try another namespace. ESXCLI space network, and now type enter. This is also space unknown namespace. Okay, sorry, there was a typo. ESXCLI network WORK. Okay, sorry. When you enter, you will find the information for ESXi network. They're given the clear information. When you type ESXi network, available namespaces. Namespaces means again network space. You can use these words. Okay, and also you can find any of the information. The same information I typed here. See ESXi network. This is also one of the name information IP, and one of the namespace information is NIC. This NIC you can find here. See IP you can find here. NIC also you can find here. Even if you want to see the virtual machines, you can use this namespace. Okay, we'll test one by one. When you type ESXi space, the namespace is network. Another namespace they given here, available namespaces. The available namespace IP. Okay, type IP space. Even if you want to see some more commands, just type IP and press enter. When we type enter, you can find again additional namespaces. Again, you can find the available command. So this is the actual command information. Okay, so commands, what is the command information? Get and set. But remember that get command is for only to display the information, and the set command is the update information. But in the real time scenario, don't use the set commands. If you are trying to test with a set command, means it will directly modify the setting on your production ESX server. Set command you can use when really is necessary. Okay, even the description it clearly says set means update global IP settings. Okay, so if you want to see the information, only the get command. So let me try the get command now. ESXi command line interface, and namespace is network space IP space, and you can type the command is get. Now enter. What the result we will get? We will get the result of all the IP setting information. Okay, now press enter. It says that IP version 6 is enabled true. So it's providing the what IP versions are available. Okay, so even if you want to see the some more additional information, what is the detail it is showing? Interface you can use, or you can use the route information. The same information I typed in our notes. See ESXi IP, either you can type connection list. When you type connection list, it is showing the how many connections are established. It's the same like a net stat command. Okay, and suppose if I type IP interface IP version 4 get, that means it will show you the IP address information. So you can just copy this command and let me paste it here. See now when I type this same IP ESXi network IP, the only namespace I used here is interface namespace. And again, the sub namespace is IPv4 get command. When we use get command, you can see the entire VM kernel 0. What is the IP address? Subnet mask. So subnet mask, we can also say net mask. Don't confuse. And broadcast, you know the broadcast very well. We already discussed what is broadcast IP. So what is the broadcast IP ends with? It ends with,
255.
yeah, 255. So it's very good. It's a 255. So that is the reason it's showing broadcast is 255 and address type is static. So we know about what is static because we assigned the ESX IP is manual IP only. So that's why it is showing address type is static IP. And the gateway we can see, and the DHCP DNS false. That means there is no DHCP configuration. Okay. So this is how we can run this command. Okay. And similarly, there is some additional commands: interface list, neighbor list. Neighbor list means what is any available nearby host. Suppose we'll try this command. Neighbor host means we also have 72 ESX. Just copy this command, go to the CLI, type this command. See, you can see our gateway IP. You can see there is another nearby system is 107.123. Whatever the interfaces are connected nearby, all the interface information you can find from here. Okay, neighbors list. And also the another one, what is this one? It is saying that host routing table. So the command is, this is the one, ESX network IP route IPv4 list. So go to the command prompt, type this command. See, route means route is nothing but a default gateway we discussed in our previous class. So route means the gateway information you can find. Okay, and also the full network. What is the network address? We are also very familiar what is network address. Network address means it ends with 0. Okay, and the specific network address, what is a subnet mask? This is a class C IP address. So subnet mask is 255.255.0 and the last host bit also 0. Okay, and our interface name is VM kernel 0, VM kernel port VMK 0, the same one, and the source is a manually assigned IP. Okay, so that's how we can verify the commands also from the command line level. And similarly, you can practice the remaining ESXi network commands. If you observe the last two commands, it's a different. It's not like CFG and ESXi. It's a separate command. If you see, the first command is NC. NC means we can also call it as netcat connect. It's also network connection status command. So to verify the connection port. What is the syntax they given is NC space hyphen Z and the destination IP address and port. Okay, destination IP address and ports. For example, in our lab, we have a two ESXi host. ESX1 is running on 71, ESX2 is running on 72. So we can try to check on the 71 to 72 connection status. Let me clear the screen. When we clear the screen, let's type the command is nc space hyphen z space. And what is the syntax? We need to type destination IP. Okay, what is our destination IP? Our second ESXi host IP address 192.168.10.72. Okay, we connected the IP address is 71. Now I am trying to connect it to the 72. Okay, when connected to 72 under destination port, we are trying to test the port test. So by default, ESX server is connected with which port? HTTPS. HTTPS means port number is 443 and HTTP means port number is 80. So we'll trying to test the any one of the port. So let's say the port number 80. Now press enter. What is the result we are getting? Connection to 192.168.10.72.80 port connection is succeeded. Suppose I want to test another port. Let's say the port is 443. 443 is a secure connection port. If the port is not available means it says as connection is unsuccessful. Seems it's taking longer time. So that means most of the time maybe no connection from ESX1 to ESX2 for the 443 port connection. If you want to exit the screen, press Control C or Control X. Okay, I just exited the command session. Okay, so that is about the this command. This is also we'll use in the real time when we want to test the any of the specific ports. Okay, excuse me. And another one, test the connectivity to remote ESXi host. Either you can use a normal ping command or you can use the command VMK ping. So we'll test the both. Normal ping command, we already know. Ping full form is packet internet gopher, and you can type the destination ESX host 192.168.10.72. When we type, see we are receiving the reply. Okay, the packets, how many packets it sent? Only three packets. So the same one, three packets transmitted, three packets received. There is no loss, zero packet loss. Okay, so same one, we can also use the another command. It is a VMK ping. So you can type VMK ping space and our IP address 192.168.10.72. So this is also same functionality, same like a VMK ping and VMK ping. Okay, anything you can use in the real-time scenario when you want to trying to verify the connectivity test between your ESXi servers. Okay. So this is about the ESXi networking commands information. So we observed ESX CLI command, we observed ESX CFG and two additional commands. Okay, so now it's the time for our lab. Okay, we'll start doing the lab one by one. The first one is vSwitch creation. Okay, so let me log into our lab system. We'll connect to our ESX second ESX 72 because our ESX1 we already have multiple switches. So we'll connect to the ESX2 root and we'll create the login with the root password. Okay, now we log into the ESX server. When we're trying to access our ESX server, select the networking. Okay. When we connect the networking, right side we have multiple tabs. So we'll quickly talk about what is the importance of each tab. The first tab refers as a port group. It will show you what is the available ports, port groups. Okay. And the second tab is virtual switches. How many V switches we have? Currently we have only one virtual switch, and this switch connected with 6 port group, 5 uplinks and standard switch. Okay. And also now physical NIC cards. Let's verify how many physical NIC cards is. 5 physical NIC cards we have, 0 to 4. And VM kernel NIC, we have 2 VM kernel NICs. Okay. And TCP IP stack. TCP IP means transmission control protocol and IP stack. This is also one of the TCP/IP stack. It maintains all the gateway IP information. See, one TCP/IP stack for VM kernel and one provisioning stack for provisioning gateway, and vMotion stack also have a separate gateway. To maintain all the gateway information, it's configured under the TCP/IP stacks only. See, even the line is like this. If you see here in this visually diagram, one line dedicated for vMotion stack, one line dedicated for provisioning stack, and the third line dedicated for TCP IP stack. Okay. And the last tab is firewall rules. Under firewall rules, there are default firewall rules when we install a ESX server. Suppose some default firewall rules, just now we tested the port 80 is enable state. Where we can see port 80 is, let me sort out with the numbers. We can see the port 80, see port 80. The port 80 is default vSphere web access. We are connecting with the web access port number is 80. So that's the reason we are able to access. And similarly, vMotion port number. What is the vMotion port number is 880. So these all port numbers you will find from the firewall rules. Okay. There are some firewall rules. It is the none or some of the in the running state. In case of any port is not running or anything, we can just select actions. We can go to the service section and we can either restart or start. Okay. Suppose we'll verify the none one, any option for the none. vSphere client 443 port. Select actions. Here only the disable option only. There is no service start or anything. Okay. So default is enable state only 443 port. Okay. So now let's talk about our lab points. The first one is vSwitch creation. Okay. So vSwitch creation. Now I'm going to create a new virtual switch on the our second ESX host. Just now we verified when we select the networking tab, virtual switches, we have only one virtual switch. Now I'm going to create a second virtual switch. So there is a option for add standard virtual switch. You can choose here, or else when you right click here also you have an option to add standard switch. Any option you can use. Okay. So based on your convenience, right click the networking, select add standard vSwitch and enter the name. The name you can put any of the name. For example, we want to test the use case one. So I just, for easy understanding, use case one vSwitch, vSwitch demo, or else vSwitch use case one. For use case short form, I will put the UC hyphen one. Okay. And the MTU default max transmission unit is 500. No need to modify this one. Just leave it as it is. And link discovery, we already know the link discovery default options. The link discovery says as a mode is listen, or there is a multiple option. Better leave it as a default listen mode. Okay, and protocol. The default link discovery protocol is Cisco discovery protocol only available. Cisco means normally most of the systems Cisco switches only. The default link discovery protocol is Cisco discovery protocol. And when we expand security, see we have a default security policies. Security policies are promiscuous mode, MAC address changes, 4G transmit mode. Now click on and no need to modify anything. Just go with the default option. Click on add. Okay, so use case one switch is added. Okay, suppose I want to configure a use case two also. Let's say again the same way, if you want to create another vSwitch, same method, right click the network, select add standard vSwitch, click here. You can see the switch icon plus icon. So just click add vSwitch. Now you can mention the name. Let's say I want to create another vSwitch. Name will be our convenience, any name we can keep. So let's say use case 2 we want to practice on this switch. I'm selecting the nick as a use case 2. So use case to use the default settings, click on add. So switch creation is pretty simple. Just use case 1, use case 2, we created here 2 virtual switches. So hope we understand the first point. So now let's come to the second point. Creating a VM port group. So go to the vSwitch use case 1 switch, go here. And if I want to create a port group here, what is the options are available? Just select the action. There is option to uplink, means we are adding a physical link, or else just right click the virtual switch. You will find here no option is showing. So that means the let me try from the edit settings. Even in the edit settings also we can add only the uplink only. We cannot add port group from here. So the best option is select the networking tab. Under networking tab, when we select networking tab, right pan, go to the port groups. When we go to the port group, you can see add port group option, or else right click the network, you have an option to add port group. Okay. So any method you can use. So when we click add port group, we need to choose the switch name, port group name, sorry. So port group name, which port group name we can choose is, let's say this is use case 1 switch. So what is our use case 1 switch port group name? We have a multiple port groups here. Let's say the port group name, I want to create the port group name as a production. Full name I want to use production. Let's put the full same name, production. Okay. And VLAN ID, leave it as default. Because we don't have a physical network VLAN information. Normally, if you have any physical network VLAN information, you can enter here. Okay. And virtual switch, this port group, where do you want to create? We want to create only on a use case 1 switch. So select use case 1 switch and expand security policies. This one also, see, if you observe the port group policy information, it's a default inherit from a virtual switch. Okay. Now click on add. Okay. When you see here production port group already created, this is added under the vSwitch one. Again, click on vSwitch, you will find the full diagram here. But when we see this diagram, there is no physical adapter. Okay. Physical adapter also we need to add. Even that is also a part of our lab. One of our lab for the adapter also. See, creating a VM network port group. And the fourth point is adding a NICs to virtual switch for redundancy purpose. So if you want to add uplink also we can add. Before adding uplink, first we can observe the VM kernel port group also. So VM kernel port group, how we can create is select your virtual switch. When you select the virtual switch, default here there is no option to create a VM kernel port group. So in order to create a VM kernel port group, again go to the networking tab. Either you can go to the VM kernel NICs tab, add VM kernel NIC from here, or else right click the network. You can see add VM kernel NIC. So most of the time, all the options are available in a right click of network options. vSwitch addition, adding port group and adding the virtual kernel NIC. Either you can use this method or you can go to the VM kernel tab, add the VM kernel NIC. When you click VM kernel NIC, and you can choose the new port group name. That's how we can create a VM kernel port group. Okay. Our VM kernel port group name, as per our vSwitch one, use case one, what is the name we have? The same name we can follow. Here the iSCSI is the one of the management port group. Management means it's a VM kernel port group only. So we'll put the name as iSCSI. So let make the name as iSCSI. When I select iSCSI and virtual switch also, we need to choose which virtual switch I want to create this port group. I want to create on a use case one. So use case one vSwitch, I created a iSCSI port, VLAN ID default and MTU also default, IP version 4. This is important. When we creating a VM kernel port group, we need a IP address. It should be either DHCP or static, but most of the real-time scenario, we use static only. Okay, let's expand here and you can enter the IP address here. Okay, so let me choose one random IP address within the class C. 10 dot, for example, I'm giving 76. Before confirm, we'll just try to ping whether this IP is available or not. Ping 192.168.10.76. See, when we ping the 76 IP, we are receiving as unreachable. That means IP is not in use. It's the available IP address. We can enter here. Okay. Now you can enter the subnet mask 255.255.255.0 because it's a class C. So three network portions, one host portion. Okay. And the TCP IP stack, default TCP IP stack, or you can choose any specific stacks here or else leave the TCP IP stack. Under the ESX services, you can choose relevant service from here. Okay, I choose the service as a iSCSI. Normally iSCSI for a storage purpose. The why we are choosing the storage is provisioning the VMs under the storage. So select provisioning is the relevant service. Click on create. When click on create, see under the VM kernel NICs, we have a three management port groups are created. This is icon for port group. One management port group refers as management network, another one refers as vMotion, and another refers as a iSCSI. Okay. Now, when I select the vSwitch use case one, now you can see the picture of under the vSwitch one, we created one vSwitch first, and we added a VM network port group, and we added a VM kernel port group. Okay. So one, two, three. Three labs are we done. So our three labs are we completed just now. We switch creation, create VM port group, VM kernel port group. Now the fourth point is adding the NICs. How we are going to add the NIC to virtual switch. So if you want to add the NICs to the virtual switch, first of all, we need to verify whether we have a available NIC codes or not. In order to verify the NIC codes, again go to network tab, right side, you can see the option for physical NICs. So select the physical NICs. You can see here we have a 5 NIC codes. But out of 5 NIC codes, we can observe the vSwitch 0, how many NICs are assigned. See here already how many NICs assigned? 5 NICs assigned for a vSwitch 0. That means there is no free NIC cards. In that scenario, if you want to distribute this NICs to the another vSwitch, the only method is we can remove the NIC cards from this vSwitch. If you want to remove the NIC cards, but in the real-time scenario, it's a big challenging task. We need to verify whether this NICs there is no dependency networks. Until you confirm there is no dependency network, then only we recommend to disable those NIC cards. Okay, if you want to disable or remove from this vSwitch, go to the edit settings. When you go to the edit settings, you can see all the NICs. Uplink 1, 2, 3, 4, 5. Let's say I planning to keep only two uplinks. Let's remove the another uplink. Okay, so three uplinks are removed from vSwitch 0. Just click on save configuration. See, our vSwitch is updated as a 2 NICs. Now we have a three spare NIC cards. These three spare NIC cards we can plan to use for a vSwitch 0 because vSwitch use case one switch. When I select this switch, expand vSwitch topology, it clearly says that no physical adapters. If you want to add physical adapters, again the same method. Click on edit settings. When we select the edit settings, you can see the option for add uplink. So click on add uplink. It's added one uplink. Okay, by default it choose the available NIC card VM NIC 2. If I want to add one more NIC card, again click on add, see VM NIC 3. If I want to add three NICs at a time, click on add three NICs also you can add. Okay, so you can add maximum for vSwitch. If I have a 10 Gbps speed NIC here, 10,000 means it's a 10 Gbps speed. How many NICs we can add for virtual switch? If my network speed is 10 Gbps, maximum how many NICs we can add?
16.
Yeah, very good. We can add 16 NIC cards. So I'm just showing you the how we can add 16 means this is the way we can add the uplinks. Okay. So for our easy understanding, minimum recommended is at least two NIC cards. So let's remove the third NIC. I'm keeping the two NIC cards. And the policies and all same. We no need to modify any settings. So just click on save. See, physical adapters, two NIC cards are added. See, you can see the vSwitch topology, even the connection also established. From the VM kernel 2, when I select VM kernel 2, the connection is going from VM kernel 2 to vSwitch, from vSwitch to physical NIC, the connection is established. Okay, so we observed the Fourth point also adding the NICs to vSwitch, and we also mention as for redundancy. So for redundancy purpose, we added minimally two NIC is recommended for redundancy. When we add a two NIC cards, in case of one NIC card is down, immediately another NIC card will maintain the entire load. Okay, and now observe the vSwitch connection policies. So vSwitch connection policies, how we can observe? Just go to the networking tab and you can choose any virtual switch. Suppose if I select vSwitch 0, you can observe the connection policies from the vSwitch summary tab itself. See, you can find the vSwitch details, speed, and also the how many ports are in used, protocol. Here you can find the policy information, NIC teaming policy, security policy, shaping policy. Okay, the same policy is available on a another vSwitch also. When I select the second use case switch also, you will find the same policies. This policy is applicable not only for the switch level, even if I want to click the any specific port groups. Let's say I want to click on the one of the port group VM kernel 2. Even when I click on port group also, you will find the same port group policies available on the port group level also. If you click edit, you will find the same kind of policies here. This is all the service section. While creation of port group only, we notice the policy. iSCSI port group, you can see policy information, security policy, NIC teaming, and shaping policy. Okay, direct when we click on port group only, we can see policy information. So policies are same for vSwitch level as well as port group level. So fifth point also clear. Now assign the specific port groups to production and test VMs. Okay, now log into the same ESXi host and verify how many VMs we have. Current virtual machine count is 0. So we quickly create one virtual machine and we trying to assign a one network card for a virtual machine. So how we can assign is create virtual machine. This portion, let's go a bit faster because we already know how to create a virtual machine. Let me select the OS. Let's choose any latest Windows version. Click on next. And here it's saying that no items to display. That means currently there is no storage because we install the ESX host only on a one hard disk. If I open a workstation, this is our ESX72. Okay, if I open the ESX server, right click the host, go to the settings tab. We have how many disks? We have only one hard disk. It's assigned for a operating system, but there is no additional disk to create a virtual machine. So this scenario, if you want to add additional disk in the real-time scenario, we can add a external storage, either a NAS storage, SAN storage, or network attached storage. Anything we can add in the real-time scenario. But in our test lab, we can just try to add a additional local disk. Okay, so let's click on add, select the hard disk, and hard disk choose the default option. Let's say I'm trying to add some hard disk now. So always choose single file. For example, I'm adding the hard disk size as a 50 GB. So click on next. Virtual machine disk file name is vmname.vmdk. Click finish. Okay. Now click on OK. Normally in the Windows system, we will log into Windows operating system, we will extend the disk space. But in the Linux or ESX operating system, in order to apply the newly added disk on the host level, see here there is no disk here still. So in order to, even if I select the storage also, there is no disk. If I click the new data store also, it won't shows the any drives here. In order to detect the new drive, new 50 GB drive, it requires a ESXi host restart. Okay, so before restart the ESX host, what is the recommended step? Right click the ESX host, place the host into maintenance mode. Okay, when you click maintenance mode, the host is in the maintenance mode. Now we can go to reboot. You can reboot from right click the host, reboot, or else we already connect to the ESX host command line. Also, we can use the command reboot command. Okay, we'll try to reboot from the command line method. So right click the putty, new session. Let me type the second host IP address 192.168.1. And the IP address is 10.72. See, it's showing the error message. That means SSH session is not at enable here. So let me quickly enable the SSH session. Exit the maintenance mode. How to enable the SSH mode here? Select the ESXi host. How we can enable?
Go to services.
In services.
Go to the manage services section and select the SSH. When you select the SSH actions, you can start or else you can click here also. Okay, SSH session is running state now. We'll try to reconnect again. Right click, new session, 192.168.10.72. See, now we are able to log in. Root and password. Let me increase the font, change settings, appearance, font. Okay, so if you want to reboot the host, command is reboot, but before reboot, just place the host into maintenance mode. So host is in the maintenance mode. You can see the message maintenance mode. Now log into the host via SSH and type the reboot command, enter. Okay. Once it's rebooted, immediately your session will be disconnected. See, the session is disconnected already. Closed the network connection. Okay. Even the session it is showing as inactive state. We'll monitor the status from our workstation also. Suppose in the real time when you restart the ESX server, if you want to see this kind of screen, we need to use for HPE servers, we need to connect to the ILO. ILO means integrated light source. For Dell servers, ID rack, integrated Dell remote access control. For IBM servers, RSCA, remote supervisor adapter. Names are changed from the one server to another server, but the concept is same. Still, if you want to see your server is in the remote location, you want to connect your server and want to see the current status, use the ILO or Dell ID Rack or IBM IRMC. If you are using a Fujitsu, also have a RMC IP. So that is a way we can verify in the real-time scenario. But in our lab system, it's a simple. You just connect to our workstation, verify the host is boot up or not. When I see the ESX2 now, see it's completely boot up. Now again connect to the ESX72. Just refresh this page. It will prompt you for the password again. Okay, now we log in. It's in the maintenance mode. So exit the maintenance mode. Select again, right click, exit maintenance. So in the recent task, you can see the status exit maintenance mode completed successfully. So now it's the time to add the storage first. Once we add the storage, then only we can create the virtual machines. Okay, so select the storage, select a new data store, create a new data store, click on next. See, it's automatically detected our new 50 GB disk. Okay, it's clearly says that it's a local disk only. Local VMware disk 50 GB is added. Okay, this addressing and all don't confuse. This address and all I will explain clearly in the storage class. And now enter the name, any name you can keep. Let's say local data store 1. I'm putting the name as local data store 1. Suppose in future if I create another local data store, we'll maintain the name as 1, 2 and so on. Okay, so local data store 1, click on next. See, before select a partition, we have free space 50 GB. Once we create a partition, partition is changed to VMFS partition. VMFS means virtual machine file system. It is similar like our Windows file system. Windows also we have a file system called NTFS, new technology file system. Even in the Linux operating system, we have a file system called EXT. EXT4 is the file system. Same way in our ESXi also have their own file system. The file system name is VMFS. So entire 50 GB disk going to format with a VMFS file system format. So now use the default option, click next. See, local disk is going to create VMFS 50 GB, click on finish. See, the entire contents of the disk going to format, it's fine, click on S. See, now local data store 50 GB is created. Okay, so current VMFS version is VMFS 6, virtual machine file system version 6. Now it's the time to create a virtual machine. Now we have a disk is available, good to create the VM. Click on create virtual machine. We'll choose the VM name. Let's say VM01. Choose the operating system family and operating system version. Version is 2022. Click on next. See, now we are able to detect our storage. Previously there is no storage actually. Okay, now click on next. It's saying that the size is greater than, just close. See, here we can because it's showing error message by default 90 GB. We don't have 90 GB space here. So let's give the minimal space, 10 GB or 15 GB, whatever size you want. Within our 50 GB size we can assign. Okay, I assigned as a 15 GB. And there is a disk provisioning type, thin, thick and all. These three also I explained clearly in the storage session class. Okay, just remember these words, it's important. Thin provision, thick provision. Okay, VM is ready to create now, finish. See, VM01 is created now. Now our actual lab topic is assign the specific port group to production and test VMs. So we already created one VM, quickly create another VM also. Next, choose the VM02, or we'll say test VM, test VM02, or without number test VM. I'm choosing any OS family, let's say Linux, and operating system also Red Hat Linux. Red Hat Enterprise Linux latest version or 9 also released. Okay, we'll choose 8 first. Storage space, same storage, and the size default 16. Oh, we have enough space. Now click on next, click on finish. So we haven't changed any network settings. By default, whatever the settings available there, I quickly created the VMs 2 virtual machine. Now our plan is virtual machine 1, I plan to add it to a we see our virtual switch, and also I'm planning to add under the production port group. If you want to add this virtual machine under production, how we can add is go to the specific virtual machine 01, and right click the VM, go to the edit settings. Under the edit settings, you can just expand the network. When we expand the network, you can see the options for network port group selections. Okay, where is the network? Here is the network. When you select the drop down menu, see there are all the available port groups. If I want to select for a production port group, select the production port group, click on save. When I select production port group, click on save, again go to our port group section, choose our production port group. You can see our virtual machine comes under the production. Okay, this is how we can map the virtual machine to specific port groups. Again, there is another port group, another virtual machine we created. Our virtual machine name is test VM. I want to assign this VM to the specific test and development port group. Port group we have or not will verify from a port group section. Select the networking. In the under port group section, there is a port group name called test and dev. Let's say I want to add this VM under the test. So go to the virtual machine tab, select the test VM, click on edit settings. Under edit settings, you can find the network adapter. I want to add it to the test. So select the test. This is how we can add the virtual machine to specific port group. So click on save. When I click on save, it's already added. Even if you expand the network here, you'll find here, or else if it is not updated, just go to the networking, choose your test port group, you will find the information here. See, virtual machine is added under test port group, and it have a redundancy physical NICs. Okay, this is how we can add the specific port groups to production and test VMs. So hope you understand how we can add the specific port groups. Now the another option is remove virtual switch port group and uplinks. So remove virtual switch and port group means it's a pretty simple. Log into the ESXi host, select the networking. If you want to remove any port group, just select the specific port group. Go to the action, you will have an option to remove. So click on remove. Quick remove. See, dev port group is removed. And also if I select the production, in the right side there is a one virtual machine is connected. When the virtual machine is connected, if you want to trying to delete, it won't allow you to delete because there is one virtual machine is running. So you'll get a error message. It clearly says one VM is connected. So the condition to remove the port group is make sure that there is no virtual machines connected state. If there is any virtual machine, we cannot delete the specific port groups uh, until we uncheck the virtual machine. Okay, suppose the another port group production PROD, the port group is there is no VMs are 0. So just select the production, go to the action, remove. This is how we remove the port groups. Suppose I want to remove the virtual switch. If I want to remove the virtual switch, how we can remove? We can go to the networking tab, select the virtual switch tab. We have a 3 virtual switches. Suppose if I want to remove the vSwitch 0, will it allow us to remove the vSwitch? Select virtual switch, go to action and remove only the option. But before remove, you just observe that vSwitch 0 is there any connected state? There are port groups are there and uplinks also connected. During this scenario, it won't allow you to delete until you uncheck all the port groups and also the uplinks, then only we can delete the virtual switch. Suppose use case 2 switch. Currently there is no port groups, even the uplinks also no. This scenario, if you want to remove this virtual switch, just select the virtual switch, go to the actions tab, click remove. Okay, so this is the way we can remove the virtual switches. Now, another point, what is another point is uplink. Suppose if I want to remove the uplink, how we can remove the uplink? We already observed the uplink removal. Just go to specific switch. If you want to remove one uplink from here, click on vSwitch edit settings and just to close this button. When you click on this cross mark, this uplink will be removed. So I'm just trying to remove the VMNIC 3. Click on cross mark, click on save. See, two uplinks become as a single uplink. When it is running with a single uplink, it's clearly they says that this virtual switch has no uplink redundancy. So you should add another uplink adapter. This is the warning notification message. Okay. So the solution is again need to add another NIC. So how we can add the another NIC is go to the edit settings, click add uplink, add the new NIC, click save. Okay. Suppose if you have want to remove in future also same option, go to edit settings and remove. Okay, so hope you understand all the options, how to create a virtual switch and how to create the two port groups and how we can add the uplinks to the specific vSwitch, and also we observe the vSwitch connection policies, and we also observe how we can assign the port groups to test and production VMs and removal procedure. And when comes to the use case one, under use case one, we observe that within a one virtual switch, we are creating a management port group as well as production port group. So we observe the use case one. When we see the use case one vSwitch, within the one switch, I have a multiple port groups. I have management port group iSCSI. I have a virtual machine port group production. The only difference, virtual machine port group, there is no IP. IPs are only inside the VM. And VM kernel port group have a specific IP addresses. Okay, this is the use case one scenario. Suppose comes to the use case two scenario. When comes to use case scenario, instead of maintaining one virtual switch, we can create a multiple virtual switches. So we can create multiple virtual switches like this. Okay, so this one also same like our just now we observed, right? Same way we can follow the another use case two also. Okay, so you can practice this all the labs at your home system. Okay, so that's it for today. Let me know if you have any questions on this lab concepts.
Yes. Uh, what is the use of providing IP address while we are creating VM kernel port group?
Yeah, the what is the purpose is, suppose if I log into the our ESXi host, select our networking. When we select the networking, if you want to see our management port groups, we can observe from port group section, but port group section we cannot see the IP address. IP information we can see from a VM kernel NICs tab. So all our management port groups we can find from a VM kernel next tab. Here you can see all the IP address. The purpose of creating the IP address is three IP address. The main purpose is we are distributing the traffics among the ESX management services. For example, if you observe the VMK0, it's a management network and it has the IP address is 72. See, the same management network 72 IP address only we connected to host. Okay, the name itself management network means to manage our ESX server, we are connecting to the VM kernel IP only we are connecting. Okay, so this 72 IP address dedicatedly used for only to access ESX server. Suppose the second VM kernel port group, VMK1, vMotion. This vMotion also we assigned one IP address. Why we assigned the another IP address is this IP address is take care about the virtual machine vMotion traffic. If I want to move a virtual machine from one ESX server to another ESX server, during this migration also it required a one network connection. This network connection established via vMotion network only. Suppose VMK2. VMK2 is VM kernel 2 port group. We mentioned the port group name as iSCSI. While creation of iSCSI, we given the name as one of the name 76. This IP address purpose is if I want to connect from ESXi host to our storage box. In order to connect the ESX to storage box, without disturbing our manage vMotion traffic, without disturbing our management network traffic, I am created a separate network for only for the iSCSI storage purpose. Okay, so that's so to distributing the traffic. Even if you see the icons also in the TCP IP stack icons, all are in a distributed traffic icons. Suppose if I want to observe for another VM kernel, again click add VM kernel and you can choose any of the one. Suppose I just choose as a test. Okay, and test it's saying that some message we need to keep. Okay, let's say test one because there is another test is available. So I put as test one. Instead of static, always recommend is static only. So I'm giving the static IP address 192.168.10. Instead of 72, 74, 76 already in used IP address, I'm choosing the random unused IP is 77 and we enter the subnet mask 255. 255.0 and here see you can see TCP IP stack. TCP IP stack means stack is nothing but it's dividing the all the stacks traffic using transmission control protocol. One stack dedicated for management, one stack dedicated for vMotion traffic, one stack dedicated for iSCSI storage. Now apart from these three port groups, we also have some additional services. Suppose vMotion we tested already, provisioning we tested for iSCSI, fault tolerance also another service, management also another service, there is a replication also another service. For example, I want to test for a management again, so select the management. That means we are going to create a two management port groups. Select the management again, so click on create. See, now I created a test port group and test port group IP address is 77. Even when I select this test port group, you can see the test port group also created under the same virtual switch. And our VM kernel port group IP address is 77. And we created this IP, this 77 IP under the management service. So management service means this IP also can use to access our ESX server. We can test. So our new IP address is 10.77. It's loading. Even we can test the ping status also. 77. See, it started pinging. So it's taking longer time means because we already connected. Okay, it's trying to load again. It's connecting. Okay, so this is how we can connect to the management. So why, in order to answer your question, why we are creating additional IPs for vMotion and all, that vMotion IP only dedicated for migration service purpose, and another iSCSI dedicating only to handle the storage traffic. And we added a additional 77. 77 also we can use to connect to the ESX box. So if we have a two management port group, what is the benefit? Even though if our one port group management port group is down, still we can access from a another port group. Okay, so is it clear? So like this, we can create management port group for all our available services. One port group dedicated for one service. One port group dedicated for one service.
Okay.
Okay. So any other
Yeah.
questions? Any other questions?
Yes. Yeah. Is it possible to add one VM in different port groups?
Yeah, we can add. It's also good question. So when I select the VM01, currently this virtual machine is connected to production network. When we select VM in the right side panel, you can see expand the network. You will see the network is connected to production. Suppose I want to connect the same VM to test network also. In order to connect that, this existing network adapter we one network adapter we can use for at a time one port only. So if you want to use another port, what is the solution? Again, add the another NIC card. While adding the NIC card, we can choose the test. So how we can add the NIC card for this host? Go to the virtual hardware, add the adapter. In order to add, right click the VM, edit settings. There is an option to add. See, add network adapter directly. Just click on add network adapter. Default it's connected to production network here. If you want to change it to the test network, drop down menu, choose test, click on save. See, now our virtual machine 01, it's able to access the both networks. It simultaneously connect to the production network as well as it's connected to the test network. But only condition is in the guest OS level, we need to configure the IP settings also. Once we configure the IP settings, see two networks we can access from our system. Clear?
Yes.
Okay. Any other questions? Any other questions? So if no questions, we can end the session here. Okay. Thanks for your time.
Thank you
Thank you.
so much.
Yeah. Thank you. Bye for now.